Hi, in this video we're going to talk about ellipses. So what is an ellipse? An ellipse is the set of all points, so all these points in a plane such that the sum of each of the distances from f1 and from f2, so the sum of these two things is always constant. So what that means is this plus this is the same thing as this plus this, or this plus this, all the way around. The standard form of an ellipse for a horizontal, where the major is in the x direction, this is a horizontal ellipse. You see, this is a vertical ellipse because it goes up and down. But for a horizontal ellipse, it's x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the only thing that changes between a horizontal and a vertical is where a and b are. You see, a is always on the major axis. This is a and this is a. And b is always on the minor. So if it's a horizontal ellipse or an ellipse that opens up in the x direction, then the x is going to get the a, the bigger number. If it's vertical, then the y is going to get this a, and a will always be larger than b. The endpoints of the major axis are called vertices. So here's a vertex and here's a vertex. And of the minor axis, these are called covertices. So this is a covertex and a covertex. These two little yellow points, these are foci, or individually each of them is a focus. And these are always on the major axis. So just to break things down, the distance from the center to the vertices, that's A. The distance from the center to a covertex is B. And the distance from the center to the foci is C. And we also have this very important equation that C squared is equal to A squared minus B squared. That whenever we're writing equations of ellipses really comes in handy. Finally, the eccentricity, E equals C over A. This tells me how circular or ovally the ellipse looks. The closer C over A is to 0, the more circular it'll be. So let's break that down just a little bit. Remember, C is the distance from the center to the focus. If this number is really, really small over A, that gets me closer and closer to 0. So if the distance from the center to the focus is really small, you're going to have a very circular looking ellipse. See, this distance is not very small, so we have a very stretched out ellipse. All right, so let's try and graph this ellipse. So first I'm going to find my a squared and b squared. This is the larger number, so this is a squared. This is b squared. That lets me know that since a squared is underneath the y, this is a vertical ellipse. Just like with circles, I can look inside the parentheses to see that the center is at -1, 2. So the very first thing I want to draw is my center at -1, 2. Now, a squared was 25, so a is equal to 5. That means I'm going to go up and down 5 since it's under y. That gives me points -1, 7 and -1, -3. Just the same ways, in the x direction, I'll go out 3 in each direction. Now I have enough points to just connect and make an ellipse. All right, so here I can see that this is my major axis, my minor axis, making these vertices and these covertices, but I need to find the focus. I'm going to use the fact that c squared is equal to a squared minus b squared. So c squared is equal to 25 minus 9, or 16. So c must equal 4. So from the center, I'm going to count up and down 4. And that'll give me a focus in each of these spots right here at -1, 6 and -1, -2. All right, lastly, I want to list the eccentricity, which is E. Well, E is just C over A, so C was 4 and A is 5. Now, because this isn't very close to 0, we can see that it's not a very circular ellipse. And there we have it. We've graphed an ellipse given its equation in standard form. All right, let's see if we can graph this ellipse. The very first thing that I notice is that its center is at -4, 4. So whenever I'm setting up my equations, I know to just use the opposite of these numbers. So I've got x plus 4 squared plus y minus 4 squared equals 1. I just need my a squared and b squared. And then I have to decide which of these gets the a squared or b squared. Well, we can see that this is a horizontal ellipse, so it's going longer in the x direction. So a squared will go underneath x. And we can see that it goes out 6 in each direction. So a squared must be 36. And in the y direction, it goes up and down 4 from the center. So 4 squared would be 16. And this is the equation of the ellipse. All right, so let's talk about general form to standard form for a second. To recognize an ellipse from general form, A cannot be equal to B, but they have to have the same sign, meaning positive or negative. So here, whenever I'm looking at x squared plus 4y squared plus blah, 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 A is 1, B is 4. They're both positive, but they're not equal. That lets me know that this is an ellipse. Now, to figure out its equation in standard form, I'm just going to have to complete the square for x and y. Start by getting your x's and y's together and your constant on the other side. Next, go ahead and factor this 4 out for these y's and complete the square. So that gives me x squared minus 2x, I'm going to leave a space for a second, plus 4 times y squared plus 6y equals negative 33. Now I can complete the square. Half of negative 2 is negative 1, squared is 1. Add that to both sides. Half of 6 is 3, squared is 9, times this 4 is 36. So now this factors down to x minus 1 squared plus 4 times y plus 3 squared is equal to 4. Last step, I need to set this equal to 1, so I'm going to divide each thing by 4. And the equation of this ellipse in standard form is x minus 1 squared over 4. Now technically you don't have to write over 1 on this next one. I like to do it just so I can see that this is my b squared. All right, and this is the equation of the ellipse in standard form. From this, you can see that it's centered at 1, negative 3. It's going to be a horizontal ellipse because a squared is sitting underneath x and all that stuff. All right, well, that's it for ellipses. Goodbye.